August 2025 witnessed the awakening of a volcanic system. Not within Iceland's borders, nor throughout Italy's territories. Instead, within Russian boundaries, seismographic equipment commenced detecting tremorous activity. Terrestrial surfaces experienced vibrations, while atmospheric conditions became saturated with sulfurous compounds and ash particles. For the initial occasion spanning multiple decades, this dormant geological giant demonstrated renewed vitality. Expert analysis suggests this phenomenon could represent the commencement of significantly more extensive developments. Considering that a singular volcanic formation possesses the capability to endanger an entire continental landmass, what consequences might unfold when Yellowstone experiences eruption? 64,000 years previously, the dormant Yellowstone supervolcanic system experienced reactivation. This event resulted in the elimination of tens of thousands of biological organisms. The most alarming aspect remains that such occurrences could manifest again within any temporal moment. During historical Yellowstone volcanic activity, molten material reaching temperatures of 1,200 degrees inundated surrounding geographical areas, eliminating all biological existence within its trajectory. Thousands of kilometers encompassing contemporary United States territories received coverage from volcanic ash deposits. Consequences included extended periods during which continental regions remained deprived of solar illumination, while seismic activities and tsunamis eliminated biological existence within multiple kilometer radiuses. Such descriptions resemble fictional apocalyptic cinematography. Unfortunately, these accounts represent factual occurrences. Scientific communities assert that supervolcanic reactivation will occur again. The possibility exists that such natural catastrophes could manifest during the current year. However, can human survival occur during catastrophic events covering most planetary surfaces? Approximately 20 supervolcanic formations similar to Yellowstone exist globally. What defines supervolcanic characteristics? Their eruptive activities can initiate climatic modifications across Earth's surface and generate catastrophic ramifications. One illustration of devastating supervolcanic explosive capabilities involves casualty statistics. The most lethal occurrence involved human fatalities during one of history's most devastating natural disasters, the Tambora supervolcanic eruption within Indonesian territories during 1815. The eruptive event itself extended across 3 days. Direct consequences of this natural catastrophe exceeded 70,000 fatalities. Hundreds of thousands ultimately perished from starvation conditions. Tambora's eruption influenced the entire planetary system. The volcanic formation expelled 185 cubic kilometers of volcanic materials. Comprehending this quantity proves challenging. Such volume could entomb Delaware State beneath approximately 50-meter ash layers. Singapore would receive coverage from proportionally smaller accumulation, approximately 20 meters. Tambora's eruptive process occurred at velocities reaching 500 million kilograms per second. This mass measurement exceeds Niagara Falls water discharge by 183 times during equivalent timeframes. However, magmatic material doesn't represent the most devastating element emerging from Tambora's depths. Ash and gaseous elevations rising post-eruption achieved approximately 40 to 30 kilometer heights. This measurement considers that standard Boeing aircraft flight altitudes fail to reach even 10-kilometer elevations. Atmospheric currents distributed ash and volcanic gases across entire global surfaces. When magmatic material appeared at surface levels, sulfur compounds, chlorine and fluorine entered atmospheric systems. These elements generated anti-greenhouse effects, causing worldwide cooling phenomena. Explosive power equivalent to Tambora's event equals 2 million atomic bomb detonations. Within several days, Tambora released energy quantities matching entire United States annual consumption. Another supervolcanic formation whose eruptive activity modified human existence was Krakatoa. This catastrophic event occurred on August 27, 1883, approximately 70 years following Tambora's eruption. Krakatoa represents an uninhabited Indonesian island. The German warship Elizabeth Captain, navigating nearby waters, observed smoke and ash clouds ascending skyward. This marked the beginning of eruptive activity extending beyond 2 months. These events caused 36,000 fatalities and destroyed hundreds of coastal settlements. Krakatoa's eruption generated the loudest documented sounds in recorded history. Auditory detection occurred across 10% of planetary surface area. Sound waves reached Australian and Mauritian territories, positioned 4,000 kilometers from Krakatoa. Two-thirds of Krakatoa Island's northern sections submerged underwater, generating lava, rock, and ash flows. Even such destruction failed to represent the most devastating consequences. The genuinely terrifying continuation involved volcanic tsunamis that eliminated all biological existence within neighboring islands' coastal zones. When Krakatoa erupted, waves reaching Hawaiian Islands and American territories, with the largest measuring 40 meters in height, struck Indonesian Banten province. Subsequently, additional wave series destroyed 165 settlements. All vegetation and structural developments on affected islands experienced complete destruction. Thousands of individuals were swept to ocean depths. Among total Krakatoa casualties, only 2,000 deaths resulted directly from eruptive activity. Tsunami events claimed 30,000 lives. Several days post-eruption, Hawaiian residents began observing brilliant sunset phenomena. 2 months later, similar reports originated from Australian and Northern European regions. Scientific analysis concluded these effects resulted from sunlight scattering by microscopic volcanic dust particles, which continued circulating within upper atmospheric layers several months later. Such atmospheric contamination can generate volcanic winter conditions across planetary systems. This occurred following Toba volcanic eruption. Scientific communities assert this natural cataclysm regressed civilizational development by hundreds of years. Speculation arises regarding contemporary achievements had supervolcanic eruptions not occurred. This catastrophic event transpired 74,000 years ago, causing volcanic winter conditions that, according to scientific estimates, persisted from 6 to 10 years. Overall, Toba's eruptive activity led to Earth's cooling effects experienced throughout subsequent millennia. Hominid and early human populations across Asian territories experienced elimination. Only limited Homo sapiens groups from African regions managed survival. These survivors developed sophisticated social and economic strategies, enabling humanity's eventual Asian repopulation. Toba eruption's volcanic explosivity index rating reaches 8, the maximum scale measurement. Toba volcanic eruption volume totaled 1,778 cubic kilometers, with approximately 360 cubic kilometers falling as ash deposits. Coverage extended across Indian Ocean areas, plus Arabian and South China Sea regions. Eruptive fragments were discovered even within East African territories. Archaeological discoveries indicate ancient human populations successfully escaped supervolcanic eruptions' destructive consequences. Within Jwalapuram, India, approximately 74,000-year-old tools were discovered. This evidence suggests small hunter-gatherer groups achieved survival. However, post-catastrophe human existence became extremely challenging. Population survival occurred under conditions where agricultural systems experienced complete destruction, while temperatures decreased to -10 degrees Celsius globally. Contemporary volcanic eruptions have occurred historically. However, current dangers involve sleeping supervolcanic systems potentially awakening momentarily. When might such events occur precisely? Global supervolcanic formations number approximately 20. These geological features are distributed across entire Earth's surface areas and exist on additional planetary bodies. Possibly their eruptive activities influenced Mars's current uninhabited status. Each formation possesses planetary life destruction capabilities. Scientific research established that within northern Mars regions, specifically Arabia Terra, over 500 million years witnessed 1,000 supereruptive events. Individual events resembled Toba volcanic eruptions on Earth, occurring 1,000 times more frequently. Research teams successfully analyzed Terra Arabia surface minerals, confirming volcanic origin assumptions. Each Martian eruption released enormous carbon dioxide quantities, creating denser atmospheric conditions that trapped solar radiation while reducing temperatures. NASA Space Flight Center scientists conduct serious research into these phenomena. However, all Martian supervolcanoes concentrate within singular northern planetary regions. Earth's formations distribute across entire surface areas. Perhaps originally they occupied unified locations, similar to Martian patterns. Continental drift and tectonic plate movements likely dispersed them across entire planetary surfaces. Currently, Earth's most powerful supervolcanic formations include Alaska's Novarupta. This formation occupies central peninsular positions. During 1912, North America's largest historical eruption occurred at this location. Initial indicators manifested 5 days before commencement near Katmai. Katmai positioning extends approximately 250 to 58 kilometers from Novarupta. These involved powerful seismic activities forcing residential evacuations. During eruption days, local populations heard multiple explosive sounds from morning hours. Several hours later, steamship Dora crew members, traveling through Shelikof Strait, observed smoke and ash from eruptive activity. Simultaneously, darkness enveloped their vessel. On neighboring Kodiak Island, positioned several hundred kilometers away, darkness achieved such completeness that flashlight beams remained invisible at arm's-length distances. These conditions persisted for 60 hours. Ash weight caused numerous Kodiak building collapses, while several settlements experienced house fires from lightning strikes within ash cloud formations. Well water became unsuitable for any consumption purposes. Eruptive consequences produced the Katmai caldera formation. Depth measurements approached 10 meters, with diameters exceeding 10 kilometers. Caldera formation resulted from Mount Katmai collapse, measuring 2,130 meters in height. This location receives designation as the Valley of 10,000 Smokes. Winds originating from this valley blow throughout autumn seasons. These air currents lift remaining ash deposits, frightening contemporary local residents. Residents perceive volcanic reawakening. However, should genuine eruption recurrence happen, Alaska could experience permanent disappearance. Ash coverage would encompass most Chukotka and Canadian territories. Casualty numbers would reach hundreds of thousands. Another concerning supervolcanic formation is Paektu, alternatively termed the Chinese volcano. Despite Chinese nomenclature, positioning occurs within the world's most isolated nation, North Korea. Unlike most planetary volcanic formations, positioning occurs not at tectonic plate junctions, but directly within central plate areas. Simply stated, Mount Paektu exists where natural laws suggest it shouldn't exist. Paektu represents sacred mountain status for North Korean populations. Peak elevations contain hot springs and gas vents, while crater areas contain basins called Heavenly Lake. However, several minor 1903 seismic events, occurring consecutively, proved sufficient for dormant Paektu volcanic systems to generate powerful underground tremor series lasting 3 years. These developments alarmed North Korean governmental authorities significantly. Such concern levels prompted unprecedented cooperation with neighboring nations to discuss evacuation assistance planning should Paektu experience explosive activity. Seismologist James Hammond secured permission for national visits and volcanic research. During 2013, he arrived at Paektu, installing 6 solar-powered seismometric devices. Network coverage extended 59.5 kilometers. For 2 years, these seismometers recorded tremor and earthquake activities. Hammond determined that Paektu underlies partially molten rock layers. Magma represents gas and crystal mixtures. Cambridge University seismologists consider Paektu among the planet's most dangerous volcanic formations. Eruptive risk levels remain extremely elevated. Paektu's most recent eruption occurred during 946 AD. This represented the most powerful eruptive event within the last 2,000 years. The volcanic formation expelled 45 megatons of sulfur into atmospheric systems. This quantity exceeds Tambora eruptive levels several times. Should Paektu experience near-future explosive activity, consequences will prove catastrophic. North Korea would experience complete territorial elimination. China, South Korea, and Japan would lose millions of citizens. Catastrophic destruction would eliminate millions of structures, contaminate all drinking water sources, generating acid rain conditions. These would contaminate soil systems and all agricultural products. Deadly global cooling awaits all Earth populations. Similar conditions occurred during Toba eruptive events. However, how can supervolcanic eruption imminence be determined? Anak Krakatau demonstrated such behavioral patterns very clearly. This formation also receives designation as Krakatau's child. Appearance occurred at supervolcanic locations that disappeared following eruptive activity. Initially representing small cone formations, the volcanic system experienced rapid growth throughout the 20th century. Surrounding landscape also underwent modifications. Ground levels rose several meters before declining. During December 2018, volcanic explosion occurred, generating destructive tsunami conditions with wave heights approaching 80 meters. 437 individuals perished. Over 30,000 sustained injuries. An additional 30,000 became refugees. Anak Krakatau eruptive activity ranks among the 21st century's most lethal events. Despite smaller dimensions than its predecessor, this volcanic formation didn't disappear post-eruption, but decreased by one-third proportionally. During 2021, underwater volcanic eruption occurred, Hunga Tonga Hunga Hapai. Local populations experienced underground tremors and heard increasing sounds several months before eruptive commencement. Several days before volcanic explosion, atmospheric conditions contained strong sulfur odors. When volcanic explosion occurred, smoke columns rose into Pacific Ocean skies, reaching heights exceeding 50 years. The enormous smoke column achieved 50 to 60-kilometer mesospheric altitudes. Explosive power proved so substantial that auditory detection occurred even within Alaskan territories. Power measurements exceeded Hiroshima atomic bomb explosions by 100 times. United Nations estimates indicate 80% of nearby island residents experienced eruptive effects. Within Tonga's capital Nuku'alofa, waves exceeding 1 meter in height advanced inland. Residents evacuated to elevated terrain and building upper levels. However, some sustained injuries from enormous stones with debris falling from 40-kilometer altitudes. Explosive force lifted materials to such atmospheric heights. Eruptive activity also generated approximately 90,000 lightning strikes. However, Yellowstone remains the primary supervolcanic threat to planetary systems. Recently, it provided renewed reminders of its presence and readiness for momentary explosive activity. One of Yellowstone's most renowned geysers, Old Faithful, completely modified its eruptive characteristics. Scientific communities now carefully monitor surrounding areas. Ground surfaces can begin ascending several meters upward within multiple meter radiuses from geyser locations. When such modifications are observed, understanding develops that conditions are unfavorable. This indicates volcanic readiness for momentary explosive activity. Should such events occur, surrounding ground levels would rise several dozen meters. Supervolcanic explosive sounds would traverse Atlantic Ocean distances and achieve auditory detection throughout European territories. Within mesospheric levels, smoke columns would ascend to space-visible heights. Merely 1 hour following Yellowstone eruptive activity, within 100-kilometer radiuses, no biological existence would remain. Some individuals would perish from explosive shockwave impacts. Others would suffocate within poisonous gas cloud formations. Furthermore, volcanic ash would distribute across all North American territorial regions. Eruptive cloud formations would cover half of national territories. Volcanic ash measures 3 times heavier than snow, causing building collapses under weight accumulation. Ash would obstruct all filtration systems within automobiles, trucks, and aircraft. Airport facilities would close. All flight operations would be canceled. Lightning accumulation within ash cloud formations would intensify thousands of times beyond normal levels, generating massive fire outbreaks. Earth surfaces would receive poisonous volcanic ash precipitation containing mercury, sulfur, and arsenic compounds. Moistened ash would accumulate on electrical lines, causing circuit failures. Populations would experience light and communication elimination, though these wouldn't represent the worst consequences. Volcanic ash would flow into river systems, rendering water unsuitable for consumption. Eruptive activity would generate mudflow conditions, sweeping away everything within their paths: vegetation, animals, humans, and structures. Nuclear power facilities would require shutdown because cooling systems operate using river water sources. Looting activities would commence. Hospital facilities would close due to supply shortages. According to preliminary calculations, 87 million individuals would perish within volcanic impact zones. 1 week following eruption, Yellowstone would distribute ash across distances reaching 1,500 kilometers. This lethal cloud formation would continue causing human fatalities. Volcanic ash consists of minute-sharp rock dust particles. Each ash particle possesses sharpened edges. Lung penetration would cause internal surface lacerations followed by death. Domestic animals would also perish and agricultural crops would experience destruction. Humanity faces the most severe famine in historical records. From Denver to Salt Lake City, only ruins would remain. Wyoming, Colorado, Idaho, Montana, and Utah states would become lifeless territories. However, United States territories wouldn't suffer exclusively. Ash cloud formations would reach European regions, causing hundreds of thousands of casualties. This would regress human developmental progress by several hundred years, possibly even millennia. Such scenarios sound ominous and frightening. Could worse possibilities exist? Actually, affirmative. More terrible than Yellowstone eruption would only be simultaneous explosive activity from all supervolcanoes. When such events occur and initial supereruptions manifest, seismic activities would shake planetary systems. These could awaken dormant supervolcanic formations and initiate chain reactions of devastating eruptions. However, would humanity survive such trials, and who would manage escape? What are your thoughts?